Hello and welcome to my tutorial today on the Void Cube. As you noticed, I've put this cube in the cube and a cube and a cube pattern already, just because I find this pattern awesome on the Void Cube. Now, for this video you will need to know how to solve the 3x3 cube, and it really helps if you can solve the 4x4 too, but it's really not necessary. It just helps with some terminology. So without further ado, scramble your cube. Now, okay, the Void Cube is obviously a different cube, considering it has no centers. But what does this do to affect our solving? Isn't it just like a 3x3? Well, that's what I originally thought, and then I discovered it had parities, like the 4x4. And there's some terminology you may need to know. So if you don't know how to solve the 3x3, or don't know 4x4 terminology, you can just jump to my videos down there. And okay, so this is pretty much the same as the 3x3 until it has the same corner parity as the 4x4 at the end. And we can do a little simple algorithm just to work that right out of the way. Okay, so as you may recall in the 4x4, there were no defined centers, and there's no defined centers here. So you had to place your pieces in the right color scheme. Like, the white is opposite yellow, and I'll declare this the white side. That blue is opposite green, and then on the left blue is red, and red is opposite orange. That should explain how to set up the cube. So let's put the centerpieces in the right order, because you notice we have no centerpieces to match up. So our second step of the 3x3, where after we get the white cross we would match the centers, it's nullified. And also you can choose any face to put any white cross on. So we have our red piece, and we know that goes on the left of blue. So let's just jump that right in there. We have our orange piece, which goes right on right of blue. And then we have, where did it jump away to? Right here. The green piece, white and green, which goes on the opposite of blue. So now you've completed your right cross. And as you see, that corner is already perfectly placed. So let's just place our other corners in, just like we would a 3x3. Also, some additional commentary is that this cube that I'm using is actually not the Rubik's The Void Cube, obviously. It is another model called a Lanvin Cube. I've heard of this company before, but they produce Void Cubes, so I got one. This company, though, as with all Void Cubes, they're linked on the inside. Like, in the inside of there, the blocks are, so it does present a problem in that there's virtually no corner cutting. You have to be perfectly aligned to turn. And also, it's kind of rusty at first, like really bad. So you're gonna have to work with it at first. Another little fact about this is that there are no mid pieces, so for those of you who are newcomers to the 3x3 and don't know how to solve the 4x4, when you have these little mid pieces right here, and you need to get this right there, most of you will be looking, as my other video stated, or every video states pretty much, if you're using the beginner's method, that you need to line it up with the centers, but now you're just going to have to line it up at the top, because, well, there's no centers. But the cube is virtually the same, very easy solve, practically as easy as the 3x3 itself, because we essentially skipped one step, and that's matching up the centers, and I use an algorithm for matching up the centers. Though I did not teach that in my video, I do use that in algorithm. So now I need one less algorithm, but there's one more parity algorithm at the end, which was fairly simple to learn. It's only about 8 steps. Okay, now I have the yellow cross. That's matched. That's matched. We need these two matched. So do our little algorithm here. My cube is still a little hard to turn. And let's try to orient our corners, and you may notice, like similar to on the 4x4, that you may be orienting corners, and this may happen. You may get one corner that matches over here, and one that matches over here, and just keep doing it until both corners are, they don't have to be, they're perfect like this, but they can be like flipped, but as long as they're in the right position on the same side. And if the other two are not, like the corner parity on the 4x4, this is how you know you have a parity. But it's fairly simple to fix. First, as I said, get both the matched corners on one side. You don't have to do the final algorithm and fix them. Just have them in the right place, because we're going to mess up the top. and then face the incorrect ones to you and do this algorithm. M, U, M, U prime, M prime, U prime, M prime, U2, M. This will, as you've seen, the white pieces are up here. It will put them all back down here in the correct order, but it will mess up our top. But if we solve it as normal now, we will have no parity errors, or should not if you did the algorithm correctly. Which, no parity errors, I always find that a good sign. Okay, and little solve it. And now, you see, we have our two correct corners again, and our incorrect ones have been correctly placed. Actually, I think it was these two, but same thing. You can always have two placed at the same time. It's just how the cube works. And now, you will not always get this parity error, so you may want to just, like, use the algorithm when it's solved, and create the parity error, and then just practice solving it off that, because it'll help you learn the algorithm, as I did. But otherwise than that, it's pretty much the same as the 3x3, and now you've solved it. And patterns I would recommend for it are the flower pattern. Some people call this the checkerboard or whatever. I call this the checkerboard or the flower. Obviously, you can't do the original flower pattern because you can't. There's no centers. You just get the same thing if you were to attempt to do the flower pattern, as I am idiotically attempting right now. And also the cube and a cube and a cube pattern is extremely amazing on this. So, thank you for watching this video. Like, subscribe, and have a good day.